Question 33. Lattice enthalpy values can be obtained from Born-Haber cycles. So that's using an ionic lattice model, making an ionic lattice, and by calculations based on perfect ionic model where atoms form perfect ions by either losing or gaining electrons. So both of these are based on ions, the perfect ionic model forming an ionic lattice. Which of these compounds shows the greatest difference from these? In other words, shows the least ionic character? Well, what about something in group 1? Something like cesium is very big right down the bottom of group 1, very large, lots of shielding. The electron, the outer electron, is far away from the nucleus, will easily form an ion. It'll have a low first ionization energy and form Cs+, lose its one electron very easily. F is very small. It's at the top of group 7, wants to gain one electron and will do so very easily because it's small. It will attract that electron close into its nucleus and will be tightly held. That electron will be pulled in, attracted into the atom to form F- very, very readily. Cesium's in there again in B. I is a large atom, so in group 7, so it isn't going to form I- and attract an electron very well because it's got lots of shielding. The electron that will be attracted will be into the outer shell, far away from the nucleus. So I isn't going to show much ionic character, but cesium is. In this one, lithium is very small and in group 1, so its electron will be tightly held, so it's not likely to lose that very well because it will be tightly held. There's no shielding, so the nuclear attraction from very, very close to that energy level, being very small and close into the nucleus, that electron will be tightly held and have a high first ionization energy, so that's not going to form a very ionic compound. However, the F is very ionic. Group 7 wants to gain one electron, very close to the nucleus, being very small, will tightly pull in that electron very, very easily, will attract that electron very, very easily and hold it tightly to the nucleus. D has got worst of both worlds. Both atoms, lithium and iodide, are not going to form ionic ions very well. So lithium, being very small, isn't going to lose its electron very well. Iodide, being very large, isn't going to attract an electron very well. Lithium iodide D is the least ionic, and that's your answer. (34) For this reaction, which combination of temperature and pressure would give the greatest equilibrium yield of the product? So which of these conditions will produce most Y and most Z? So let's have a look at temperature first of all. This is an endothermic reaction. It's a positive value. So that means that in this direction, when W and X react to make Y and Z in the forward direction, this takes in energy. It's endothermic, takes in energy. Exothermics minus gives out energy. This is endothermic, takes in energy. When W and X make Y and Z, this takes in energy from its surroundings. So if I increase the temperature, high temperature, by Le Chatelier's principle, the system opposes that change, the reaction opposes that change, and it will shift in the direction to try and lower that temperature. So if I increase the temperature, make it high, Le Chatelier's principle says this reaction will shift in the direction to try and lower that temperature and oppose the change that I've just made. So it will shift to the right hand side, because in that direction it's lowering the temperature of the surroundings. It's endothermic and lowering the temperature. I increase the temperature, shifts to the right hand side, makes more Y and Z, and lowers the temperature to oppose the change I've just made. So Y and Z, more Y and Z are made in the mixture when I make it a high temperature. So I'm looking at either A or C as my answer. Next, I have got 2 moles of reactants, 1 mole of W and 1 mole of X. 2 moles of reactants, 1 and 1 make 2. In the right hand side I've got 2 moles of Y and 1 of Z. 2 and 1 make 3 moles. So I've got 2 moles of reactants and 3 moles of product. When I increase the pressure, increasing the pressure will try and lower the volume. I will try and compress these gases by increasing the pressure, and I will squeeze or compress 3 moles down into 2 to try and lower the pressure. So if I increase the pressure, 3 moles of gas will be turned into 2 moles of gas to lower the volume and reduce the pressure. So if I increase the pressure, high pressure, 3 moles of gas will be compressed into 2, and the equilibrium will shift to the left hand side. So it's not high pressure, it's low pressure. Low pressure allows the 2 moles of gas to expand into 3 moles of gas on the right hand side and make more of Y and Z. So I'll need a low pressure and a high temperature. My answer is C.